Good morning, this is your Stat Sensei, Mr. Spensei, and this is classwork 3A.1 problems 8 through 13. This is the second video. 1 through 7 is in the video before that. It says a weighted die come up spots with the following probability. All right, so the die is weighted. In other words, it's not a fair die. Normally, the probability of getting a 1 would be 1, 6, 1, 6, 1, 6, 1, 6. But here we have 10%, 15%, 20%. I need to check to see if that's even a valid probability distribution. Let's see. So 0.1 plus 0.15 plus 0.2 plus 0.25 plus 0.2 plus 0.1. That's one whole. All right. So let's keep reading. So this added up to 1, so it's a valid probability distribution, so we can proceed. If two of these dies, anytime we do something twice, in this case we are, two of these dice are thrown, we need to make a sample space. So I'm going to need to make a table. This is not something fun, but I'm just going to tell you this is something you need to get used to doing every time you take a test or quiz. And some people make it the very first thing they do so they don't have to stress about it during it. If you practice it 2 or 3 times, you'll get fast at it. So I haven't done this in over a year, so I probably won't be that fast at it. We'll see what happens. So when I'm rolling a dice, I can get if I'm rolling 2 dice, I could get a 1 and a 1. I could get a 1 and a 2, a 1 and a 3, a 1 and a 4, and a 1 and a 5. I could get a 2 on the first dice, a 1 on the second, a 2 and a 2, and we're just going to keep going with that pattern. Oh, you know what? I could get a 1, 6 and a 2, 6. So 3 and a 1, 3 and a 2, 3 and a 3, 3 and a 4, 3 and a 5, 3 and a 6, 4 and a 1, 4 and a 2, 4 and a 3, 4 and a 4, 4 and a 5, 4 and a 6, 5 and a 1, 5 and a 2, 5 and a 3, 5 and a 4, 5 and a 5, 5 and a 6, and then finally 6 and a 1, 6 and a 2, 6 and a 3, 6 and a 4, 6 and a 5, and 6 and a 6. All right, so what is the probability that the sum is 10? Well, I just need to find out what's add up to 10. Well, 4 and 6 add up to 10, 5 and 5 add up to 10, and 6 and 5 add up to 10. So the ones that add up to 10 are these. Okay? Well, what's the probability of getting a 4 and a 6, and the probability of getting a 5 and a 5 and a 6 and a 5? Well, the probability of a 4 and a 6, so I have a 4 and a 6. Well, what's the probability of getting a 4? Oh, that's 25%. What's the probability of getting a 6? Oh, that's 10%. But I could also get a 5 and a 5. Well, what's the probability of a 5? Probability of a 5 is 20%. But I have to get it twice, so this is also 20%. Then I also have to, what about the probability of getting a 6 and a 5? Well, 6 probability of a 6 is 10%. And we already know the probability of a 5 is 20%. So let's try that out. There's no fancy way on a calculator to approach it. 0.25. 0.25 times 0.1 plus 0.2 times 0.2 plus 0.1 times 0.2 is 0.085. You know what? I'm sorry. I circled 6 and a 5. This should have been a 6 and a 4. This should have been a 4. That's going to change that probability. That should have been a 25% because the probability of 4. Sorry about that. So let's go back. 0.25 times 0.1 plus 0.2 times 0.2 plus 0.1 times probability of a 4 is 0.25. And we get 0.09. Okay, so that's the probability the sum is 10. Continuing on. What's the probability the sum is 7? Well, how do I get a 7? I can get a 7 with a 1, 6, 2, 5, 3, 4. So those right there, if I add those up, 1 plus 6 is 7, 2 plus 5 is 7, 3 plus 4 is 7, 4 plus 3, 5 plus 2, etc. All right. So this is going to be a fair amount of work on this one, and I don't have a whole lot of room. So how do I get it? I can get a 1, 6. I can get a 2, 5, a 3, 4, a 4, 3, a 5, 2, and a 6, 1. That's the way I can get it. Well, what's the probability of a 1? 0.10. And the probability of a 6 is also 0.10. Probability of a 2, 0.15. And the probability of a 5 is 0.2. Probability of a 3, 0.2. And the probability of a 4 is 0.25. Okay, probability of a 4 is 0.25. And the probability of a 3 is 0.2. Probability of a 5 is 0.2. Probability of a 2 is 0.15. And ultimately, the probability of getting a 6 is 0.1. And the probability of a 1 is 0.1. So once again, no good way to put that in there. So we're going to have to be careful with it and go 0.1 times 0.1 plus 0.15 times 0.2 plus 0.2 times 0.25 plus 0.25 times 0.2 plus 0.2 times 0.15 plus 0.1 times 0.1. And I end up getting 0.18. So the probability that the sum is 8 is 0.18. All right, the next one. What is the probability that the player's roll sums to a 7 or 11? Well, guess what? We've already done the 7. So the probability of a 7, I'm just going to write this, the probability of a 7 equals 0.18. I don't want to redo that work. That was a lot of work. The next thing it asks for, what's the probability of getting an 11? All right. So the probability of getting 11, well, how can I get 11? Well, if I look at the table, the only way I can get to 11 is 5 and 6 and 6 and 5. These add up to 11. Okay. So 5 and 6 and 6 and 5. So we need to figure out the probability of 11. Well, the only way I can get that is a 5, 6 or a 6, 5. What's the probability of a 5? Probability of a 5 is 0.2. And the probability of a 6 is 0.1. Or means add. So the probability of a 6 is 0.10. And the probability of a 5 is 0.2. And by the way, or usually means add, and usually means multiplying. I said a 5 and 6, so I'm multiplying this. Or means I'm adding probability of a 6 and 5, so those numbers have to be multiplied. So here we go. What's the probability of 11? Probability of 11 is 0.2 times 0.1 plus 0.1 times 0.2, and I end up getting 0.04. So the probability of an 11 equals 0.04. So this is the probability of it. Probability 7 is 0.18. That came from above. plus the 0.04 gives me a 0.22. So 0.18 plus 0.04 equals 0.22. This is the probability of a 7, and this is the probability of an 11. And we're adding those two probabilities together. All right. What's the probability that a player rolls craps? A 2, 3, or 12. All right. A 2, 3, or 12. Well, to roll a 2. So we're looking for the probability of a 2. Well, the probability of a 2 equals 1, 1. Okay. They also said a 3. Well, with a 3, probability of a 3 equals 1, 2, or 2, 1. And the last one was, what was the probability of rolling a 12? And the probability of a 12 is 6, 6. Okay, based on the 6, 6. So let's look at those probabilities again. Probability of a 1, well, that's 0.1. And I have to get another one. 1 and 1. And means multiply. Or means add. So this is going to be an add. The probability of a 3. Well, probability of a 3 was a 1 and 2. So 1 and 2. So and means multiply. So 0.1 times 0.15. Or is add, and 0.15 times 0.10, because 2 is a 0.15, 1 is a 0.1. Or a 12. Well, the only way to get that is a 6 and a 6. And means multiply. So in this case, we have 0.1 times 0.1 plus 0.1 times 0.15 plus 0.15 times 0.1 plus 0.1 times 0.1. And we end up getting a probability of a 1, 3, or 12 of being 0.05. All right. So this is 0.05. And that's the probability of 2 plus 3 or 12. I'm going to put up the pretty answer key here for just a moment so you can see it. All right. So here's a nice answer key so that you can look at the probabilities. This is a probability of a 4 and 6, a 5 and 5, a 6 and 4, a 1 and 6, etc. It's the same thing I just did, except it's written out a little nicer and neater for you guys. Okay. So continuing on. An insurance company charges $800 annually for car insurance. The policy specifies that the company will pay $1,000 for a minor accident, and $500 for a major accident. The probability of a motorist having a minor is 0.2, and the probability of a major is 0.05. So here's our probabilities they give us. Now, they only gave us two choices, a major accident or minor accident. Is everyone going to have an accident? And the answer is no. So you could have 0 accidents, okay? So complete the table for how much money the insurance company will make on a single policy. Probably should have given you a lot more space on this, but here's what I want to say. First off, you could have 0 accidents, a major or minor, or you could have a major accident. Well, how much are they charging? They're charging $800. If you have no accidents, how much money did they make from you? Well, if I have no accidents and they charge me $800, I guess they're making $800. All right. On the other hand, if I have a minor accident, it costs $1,000, but I only paid them 800. So how much money are they making? Well, I paid them 800, but they had to pay 1,000. That means they lost $200. So the minor accident, they lose. If I have a minor accident, they don't make money. They lose $200. And if I have a major accident, because I drive like Sensei drives, it's going to cost them $5,000. Well, I only paid them 800. They have to pay 5,000. That means it costs them $4,200. So if I have a major accident, they lose $4,200. Now the problem, zero accidents, they make $800. If I don't have any, they make 800. If I have a minor, they lose 200. If I have a major, they lose 4,200. Well, they told us the probability of a minor. They said that that was 20%. They told us the major was 5%. Well, when I add those up, 0.2 plus 0.05, that does not add up to one whole. So I have to find out what that is. So it's 1 minus 0.20 plus 0.05. So 1 minus point 1 minus, excuse me, parenthesis, 0.20 plus 0.05, and I get 0.75. So the probability I don't have I have zero accidents is 75% of the time won't have an accident. So that's actually where my table comes from. $800 for, they're going to make $800 on me if I don't have an accident. They're going to lose 200 if I have a minor, and they'll lose 4,200 if I have a major. So stat edit, and 800, negative 200, and negative 4,200. Probabilities, 0.75, 0.2, 0.05. Stat calc, one variable statistics, blue 1 and blue 2. And the expected value is $350. Please remember that's the X-bar or average. The standard deviation is 116.915. If I scroll down, I don't find variance. Remember, I always have to raise that number to the second power. So 116.9153. I like to use the caret button right here. Raise to the second. Is 13,600. Oops. It would help if I typed in all the numbers. Try it again. 6.9153. Raise to the second power. There we go. Really big one. All right. Really big variance. 1,247,499. Okay. So how much does the insurance company expect to make? They expect to make $350 per policy. All right. Down to the last one. For advertising promotion, an auto dealer hands out 1,000 lottery tickets with a prize of a new car worth $25,000. For someone with a single ticket, fill out the table for the expected winning. Well, basically, I have two choices. I could win or lose. Okay. If I win, what do I get? $25,000. If I lose, what do I get? I get nothing. All right. So the win, I get 25,000. The lose, I get 0. Well, what's the probability of winning? There's only a single ticket. So the probability of winning is 1 out of 1,000. So what's the probability of losing? The probability of losing, remember, it has to be a valid probability distribution, is 1 minus, parentheses, 1 divided by 1,000. So 1 minus, parentheses, 1 divided by 1,000. 0.999. Or if I want it as a fraction, 999 over 1,000. Okay, so that's the probability of winning and the probability of losing right there. Okay, so I can go into stat edit. And 25, 1, 2, 3. And losing, probability of winning is 1 divided by 1,000. Probability of not winning was 999 divided by 1,000, or 0.99. Stat calc, one variable statistics, blue 1, blue 2. The expected value, I expect to win $25 on average. So out of 1,000 tickets, the average payout is $25. The standard deviation is 790.17. We don't have variance, so we're going to have to square those values. 790.14 raised to the second power. And there we go. Last part. What's the expected winnings? Well, the expected winning is what you expect to win on average. And on average, we would expect to win $25 per ticket. Well, I hope this helped. Look forward to seeing you on the next one. And